Okay, good morning, Ailie. Thank you so much for joining us. We know you're a very, very busy woman, so it's very good to have you on. Thanks so much for joining us.
No problem.
All right, so look, for the listeners out there, let's start off with a little bit about who you are, what you do, for those of us that are not familiar with what you do in your work.
Yeah, sure. So I suppose you could call me a weather and climate scientist. I work for Monash University in Melbourne, in Victoria. And really, I do all things to do with how weather and climate impacts what we do. So mostly I'm a specialist in drought and understanding how kind of rainfall impacts drought and changes drought. But I'm also kind of have done a lot of work looking at things like urban heat. So this is the idea that cities can be warmer than the surrounding areas. And I've also done work in what we call climate extremes. So this is things like heat waves and extreme rainfall. So a little bit of everything, Jack of or Jill of all trades, as the case may be. And so most of my day-to-day stuff is pretty much looking at weather maps and weather data.
Wow.
Yeah, wow. Okay. Different to our day-to-day.
Yeah, that's a completely different animal.
Yeah. I'm a bit of a weather nerd and a bit of a data nerd, so it kind of suits me quite well.
Yeah.
And I suppose it's really hard to know exactly where to go because it's such a big thing that humans really struggle to understand, I suppose. But I suppose from your perspective, you're looking at, I imagine, troves of past weather data and how that's changing, presumably. I suppose, what are you seeing? Is it really changing? Because, I mean, we still have denies.
Yeah, absolutely. Yeah, and this is a question I get a lot, actually, because, you hear a lot in the media and the question is, well, come on, is it really changing? But I think the point is, at the moment, it's getting pretty obvious in people's day-to-day experiences. And I mean, certainly from the data we look at, as you said, I've done work that has looked at data that is many hundreds of years old. In some cases, we can kind of get ideas of what the climate's been like thousands and thousands, even millions of years ago through kind of what we call environmental proxies. So this is the fact that, if you cut down a tree, you see it's got rings. Well, it sets those rings every year and you can kind of count how many there are to count how old the tree is. And there's a lot of tree species that will grow a certain amount according to the weather. If it's a good year and you get good rain and good temperatures, then it'll grow more. If it's, bad year and it's very dry, it'll grow less. And so you can kind of think about the climate by looking at those things and then the observational data that we have, which we have a pretty good record of thermometers and rain gauges and stuff across the country. And then the other aspect of that is using what we call our climate models, which are basically just big digital copies of Earth that we can use to simulate what the climate does. And every single prong of evidence points in the same direction. And, people can feel it these days. It's hotter than it used to be. And in the south of Australia, it's drier than it used to be. So, yes, it is very much real. It is very much happening and will continue to happen until we really abate greenhouse gases and make a concerted effort to remove greenhouse gases as a staple supply for our electricity and everything else that we do.
Right. I think the run sheet's out the window already. I'm going to go back a second, right?
Yeah.
So, firstly, how do you go from school to becoming what you are right now? Like, how do you wake up and say, wow, I love looking at the weather? How does that happen?
Yeah, it was a really good question. Well, I never kind of knew that this was something I could do, actually. And it wasn't until I was a big science nerd. I was a big outdoors nerd. Like, I really love hiking and skiing and, mountain biking, all that kind of stuff. And so I like the two. And when I was finishing school, I'm like, well, what do I do? Not sure where I'm going to go. And I thought, well, I like this science caper, so I think I'm going to go to uni and do science. And at the time, I really liked space and I liked astrophysics, actually.
Right, okay.
Which is
that's the gateway.
That was the gateway drug for me. Okay. But it was weird.
So I was trying to figure out, where's the gateway?
Well, the gateway was that I was really into science. And so then I got to uni, though, and it was just really hard. Like, physics is really hard. And I kind of, pretty much flunked out of my first year and, just went, no, this is not for me. And there was a subject on weather, and I thought, oh yeah, I really like the weather. I grew up hit my teens in the late 90s, so Twister was a big thing. Loved Twister, and I thought, oh yeah, actually this is cool. And so then I decided that would be cool. I want to be a weather forecaster. So did meteorology. Got through that, and then someone told me that meteorologists do shift work and have to stay up all night, and I went, yeah, no. Nah. And then kind of just got into research. I did an honours year at university, just happenstance. I had a great supervisor who kind of encouraged me to do that, or a lecturer who encouraged me to do that, and then it kind of all spiraled and went from there. And I went, yes, this is my calling. Actually, I've always loved the weather. Why aren't I studying it? So yeah.
I don't know where we're going to go here, Simon, but I'm going to go AWOL on this thing. What? Have at it. All right. Yeah. So this whole thing fascinates me. There's people all over the world studying the weather, like from Antarctica to everywhere. Yeah. There's just people stationed that we don't know about. The general public's kind of, I would say exposure to the weather is the person on the TV.
Yeah.
Or the app on your phone. That's about it. Mm-hmm. Let's start at the very start, right? So I believe in global warming. I think it's happening. I absolutely think it's happening. I think it's a real problem. Can you delve into just the very basics, right, of where we're at in the world right now and what our impact as humans is and how we're impacting? Because I think that's the biggest thing. There's naysayers out that use, the 0.2%. They keep chucking that number out there to say it's all BS and rah.
Yeah.
Can you give us a summary, if you can?
Yeah, sure. Well, the first thing I'd say is we have to think about how science works. And the reality of science is that you will never, ever, ever, ever be 100% sure of anything. Now, this is getting a bit philosophical. This sounds really weird, right?
No, that's right.
Yes, right. If I get my pen and I drop it, it's going to drop on the ground, right? That's the theory of gravity. But actually, the whole point of science is to disprove things. And because we can never, ever 100% disprove or prove something, you actually will never even be 100% sure about the theory of gravity, let alone anything else, right?
Yep.
And so everyone accepts gravity. Everyone knows gravity, right? And so that's kind of the idea of science, right? So now let's move to the global warming situation. About, it would have been about 150, maybe 200 years ago now. There are actually a couple of people. There was a lady who did it first, and then, of course, her things got buried, and there was a guy who took over and published and usurped her by a year. We all know him. We don't know her. But anyway, these two looked at the idea of the fact that constituents of the atmosphere, so the gases that are in our atmosphere, so oxygen, nitrogen, everything else, right? That different types of energy can move through that in different ways. And when I say energy, let's think of light energy, right? We can think of visible light, like the light that we see, right? We know that moves through the atmosphere, otherwise we couldn't see the sun. Yeah? Absolutely. So we know the colors move through. That is a form of energy. Light is a form of energy, right?
Yep. It's what makes the world what it is.
Sorry?
It's why the world is what it is.
It is. That's right. That's why. Exactly. Because we have the sun. And so, but there's other forms, right? You go out into the sun, you feel warm. So that means there's heat energy moving through the system as well, right? But we can't see it, right? Well, you can if you've got a fancy infrared camera, but that's the point. It's infrared, right? There's also ultraviolet. We all know about ultraviolet rays. This is why we wear sunscreen, right? So what these people found about 150 years ago was that actually different gases in the atmosphere basically grabbed and held or let through energy. Think of it like an open and closed window in different ways. And they found that most of the stuff in the atmosphere, so actually most of the atmosphere is nitrogen, right? 78% of it is nitrogen. 21% of it is oxygen, and then the rest is all little bits. The nitrogen and the oxygen just pretty much let everything through. That's fine. Windows wide open. But then you have the minor gases. These are things like methane. These are things like carbon dioxide. These are things like even water vapor, actually. So water in its gaseous form. Those things, to heat, close the window, right? So basically, if you've got heat coming from particularly the Earth. Everything that exists has a temperature, right? The Earth has a temperature. It is warm. The heat from the Earth, when it zooms off into space, it's like a closed window. The atmosphere is like a closed window to a lot of that heat.
Yep.
And the thing that makes the window closed is carbon dioxide, methane, and water vapor.
Mm-hmm.
Now, the amount of water vapor in the air really doesn't change. It just cycles, right? Just goes,
it moves around.
Moves around, right?
Yeah.
Changes a little bit when the temperature gets warmer and when the temperature gets cooler. That's getting complicated. And
your Earth currents change that.
Yeah, exactly. That's right. But then we've got carbon dioxide and methane. And carbon dioxide is one of the big ones and methane is one of the big ones. And what they found was basically when you it's these two gases are like closed windows to heat. So they don't let the heat out. And so the more you have, the thicker your window. You can think of it like double glazing, right? Going from single glazing to double glazing to triple glazing, right? The more and more and more carbon dioxide you put in. And then after those people found this 150 years ago, a couple of people in the early 20th century went, oh, actually, these people did these studies and we're kind of seeing these small increases in temperature from the thermometers that we have.
Yeah.
Actually, maybe this is a bit of a problem. And then by the 50s, people were like, oh, yes, we're actually starting to see these increases. And then they started putting in observing stations for carbon dioxide, which is it's what we call very well mixed in the atmosphere. So that means that even though it might be emitted from a smokestack here or a smokestack there, it actually lasts in the atmosphere a really long time. And so you can think of it like pouring, I don't know, food coloring in a cake and mixing it up really well. Eventually it just gets all mixed up.
Yeah.
Really, really well. And so the point is that carbon dioxide gets mixed up really well. And so they put in these observing stations, one in Hawaii, which has unfortunately just been closed, and another one, Tasmania. Mm-hmm. So there's actually another one on the northwest coast of Tassie at a place called Cape Grim.
Yep.
And both of these places measured the cleanest air in the world. It was all coming off big stretches of ocean. And both of those show these really big increases in carbon dioxide, as do a whole bunch of other places around the globe. And so we're seeing increases in carbon dioxide, associated increases in temperature and other changes in the climate. And when you look at how these things are changing through many multiple lines of evidence, you mentioned the 2% or something before. I actually know the guy that wrote that study.
Yeah.
And, he tried to he did update it a couple of years ago and he's been updating it ever since. And that number is getting smaller and smaller and smaller and smaller. And quite frankly, there are vested interests in the people publishing those studies with that number. Yeah. And it's just, there is no question anymore. In the scientific community, in the broader scientific community, there actually hasn't been a question for, a good 30 years. We've all been on, singing from the same hymn sheet. And that's not because we're validating each other's studies. In fact, scientists are a bit of a competitive bunch. And so we actually try and discredit each other's studies. That's the whole point of what we do. So to be sitting there and trying to discredit what each other's doing and saying, no, your theory is wrong, and yet we come up with the same answer again and again and again. And in fact, the most famous one of these was a physicist from Stanford, from Stanford, top university in the world in the United States. He was like, nah, this thing is just not true. I'm going to get all the observational data and I'm going to get this and I'm going to get that and I'm going to prove it's not true. And he was even paid by some people who were hoping it wasn't true. Mm. And in the end, he went, actually, it is true. I was wrong.
Scientists can't lie.
And he's like, I don't care that you've paid me, but this is happening. And after a big 5-year study, he's like, yep, sorry, this is it. So there really is consensus. I mean, put it this way, during the last phase there's a big international report that's released every 6 or 7 years from somewhere called the Intergovernmental Panel on Climate Change, which is basically the world's scientists and a whole bunch of bureaucrats getting together to agree on what the science is. Mm-hmm. These are bureaucrats, right, with countries, with their own interests and everything like that. Even every single country in the world, and it has to be a unanimous statement, agreed that the fact that the Earth was warming and the fact that humans were affecting the Earth system via climate change was, they use the words, virtually certain.
Yeah.
Now, that is as strong an agreement as you will ever get internationally. Think about the UN and how they disagree, and
everybody disagrees about something.
That's right.
Yeah.
And so to get such a unanimous statement was like even us scientists were pretty shocked that that was that strong and that unanimous.
So to take the techie out of it, right? In layman's terms, our atmosphere and our air and everything is essentially a filter. And that filter allows the heat from the earth to escape to space, for want of a better word, or radiation to escape to space. Right now, our filter is getting dirtier and dirtier and dirtier because of the carbon dioxide. And therefore, it's harder and harder for that heat to escape. So the heat can't escape from our atmosphere and our world. It just continues to grow. So it's no different than if you're in a house and it's full of brick, and just think like a house it's a brick and concrete house, right? And you've got no aircon and the sun is hitting it and it's beaming in and it's beaming in. And then the heat is just constantly increasing inside the house.
That's right. That's
it just can't get out.
That's a brilliant analogy. Exactly right.
So it's, for in layman's terms, I think of it like a sieve. There's a sieve outside the world, and the sieve is just dirty. It's like a filter. It's dirty. He can't get out. But the process of diluting our atmosphere from what we've already done is, it's, I wouldn't say it's irreversible, but for me, it's not far off it.
Well, it's a very hard ship to turn around, right? Now, it is possible because the Earth naturally has processes that effectively act like a sponge to carbon dioxide, right? So if you want to think about your filter or your sieve, there's parts of the Earth that naturally kind of clean that filter, right? The problem is...
you're talking about like trees and plants.
Yeah, trees and plants, exactly. So they take carbon dioxide, trees and plants... rock processes, so what we call weathering processes from rocks, although that happens on kind of timescales of hundreds of thousands to millions of years. But we have these processes, and it's more than just plants. It's also the ocean as well, and a whole bunch of other things. But they kind of act like a bit of a filter to carbon dioxide, right? And so, not filter, sorry, a scrubber, right? And so they clean that filter, but the problem is the rate at which they can clean it is a lot slower than the rate that we are clogging it. We're emitting more stuff to clog it much faster than it can be cleaned. And so when you have that imbalance, because normally the Earth is, if we're not emitting the extra stuff, normally the Earth is in balance. And, yes, things are getting clogged, but they're getting cleaned at the same rate. So we're all good, right? But now... we're emitting stuff that means that filter is getting clogged at a far quicker pace than the natural scrubbers can scrub it, basically. And not only that, we're getting rid of some of the scrubbers. You mentioned trees and plants. Deforestation is a big issue as well. That means that those scrubbers, the cleaners of our filter are, it's not what it was, right?
Yeah. I think as a race, I think we're only here for a short time. I have this belief that the Earth is a biological wonder and it will repair itself regardless. Now, whether we're going to be along for that ride, the Earth will decide. We won't, the Earth will. The Earth will just tell us, you can either hang on and come along with me, or I'll extinguish you.
Absolutely.
And I will just repair myself.
Absolutely. And you can see this throughout history, right?
Yeah,
I mean, you think of you can see this throughout very long timescale history. Like if you think about, the death of the dinosaurs, and you think about, we've been through cycles that get very, very warm. Like the Earth was warmer at the time of the dinosaurs. The Earth has been through big glacial and interglacial cycles, which means that sometimes the Earth had huge ice caps, much bigger than today. Like half of, pretty much all of Canada into North America was covered by an ice cap. I think it was only a couple of 100,000 years ago, right? So in the grand scheme of the life of the Earth, which is 4 billion years old, not that long ago, right? Humans were definitely around at that time. But the Earth has a way, as you say, of equilibrating itself. So, for example, one of the concerns that scientists have at the moment, which is just we really don't know a lot about, is that when we've had these big warm cycles happen in the past naturally, which sometimes they have happened naturally, just not at the rate we're seeing today.
Yeah.
Right? Much slower, much slower. So when they have happened, big ocean circulations have shifted and changed, which very rapidly and suddenly cooled the Earth.
Yeah.
And so one of these is in the Atlantic Ocean. And this is a concern now that we have potentially seen a slowdown in this circulation that kind of moves heat away from the tropics in the Atlantic up towards Greenland, basically, and Iceland. And it basically is why Western Europe has a relatively mild climate, even though they're very, very far north.
Yeah.
I mean, England is farther north than, if you think of equivalent to Australia, it's way further south than Tasmania, right? And yet it has a climate that, for where it is actually relatively mild. And it's because of this ocean circulation, right?
Yeah.
But there's evidence that if that ocean circulation suddenly shut down, they would be plunged into pretty severe cold.
Arctic.
Yeah, well, subarctic, exactly.
Yeah.
And so that's how the Earth kind of equilibrates itself. And as you say, Brian, it's just going to take us along for the ride. It's the question of whether we are adaptable enough to deal with that. For example, the dinosaurs weren't when the big meteor hit, right? Because they didn't have systems in place that they could, get over the fact that they were very cold all of a sudden and there was no food.
Well, we don't own the Earth.
No, that's right.
We're just, another biological form that's on the Earth at the moment. And if you look at the millions of years and the different biological forms that have been,
Yep.
if we don't respect it, it's just going to chuck us out.
Absolutely. In fact, it's really funny. My 6-year-old son asked me that question last night. He said, Mum, what comes after humans? Because he loves dinosaurs. And he's like, well, humans came after dinosaurs. So what comes after humans? And I'm like, it's a really good question, buddy. I don't know, actually.
It is a good question. And Ailie, there's a real bit of a downer, a lot of this. But isn't I read an article. I often read The Economist, and on the weekend they had one about the Earth's ability to absorb re-emit warmth, due to lots of reasons, but mainly being a lack of ice. That it can expel heat. So with obviously a reduction in ice caps, this sort of cycle of warming accelerates.
Yeah, so this is the unfortunate thing is we can get we have lots of things in our climate that we don't understand called tipping points and feedbacks, right? So these are kind of two different things. I explained one feedback just before when I said, you shut down this ocean circulation, all of a sudden you go from this thing where Western Europe's like quite warm and then boom, down, immediate, and when I say immediate, I'm talking within a year or two.
Yeah.
Kind of really cool. That's what we call the tipping point. And then we also have these things called feedbacks, which is what you're describing, Simon. So the idea is that, our ice caps act like a big mirror to the sun's rays, right? And so when the sun's rays come in over, say, for example, open ocean, which is kind of dark if you look at it from above, that absorbs a lot of the sun's heat, whereas ice caps, which are white, are like a big mirror and they reflect a lot of the sun's heat. Because ultimately that's where a lot of that heat that the Earth has comes from. And so if you've got fewer ice caps and less ice, then you have less of a mirror and less of a reflection, and you've got darker surfaces, which means that the sun, the heat that does come from the sun is more likely to stay here than it is to be reflected back into space. And so that's what and so of course you've got a bit of a snowball effect part of the fun with the ice, but you've got a snowball effect where you've got less ice, meaning that more is observed, meaning it warms more, and then it gives you less ice because it's warming more, and so on and so on and so on and so on.
It's almost like I wouldn't say a runaway train, but
it is. Yeah. Until we hit the point where we have no ice. Now, I don't want to terrify your listeners because the reality is that the time it would take to melt all the ice is a very long time. Like we're talking 1,000+ years. But the problem is that there's a heap of inertia in the system. Like you say, a runaway freight train, it is very hard to stop. And so the problem is that now we might be setting that train in motion and not necessarily being able to pull it back unless we really, take our foot off the gas with emitting greenhouse gases. And so, you talked about being a downer before, Simon. There is actually a super simple solution to all this, like super simple when you think about it. And that is we just need to stop emitting greenhouse gases, and we need to have a rapid transition to, I don't care what technology it is, whether it's better homes built with better insulation and we just do a better job of that, whether it's, there's hydrogen as well. We think about, we can make hydrogen fuel, or whether it's electricity from renewables via solar and wind and all that, any of that. The point is that we just need to get to, we just need to lower emissions. That's all we need to do. And if we lower emissions, we give ourselves the best possible chance of avoiding the worst of this. Because this doesn't, you often hear, by 2100. This doesn't stop in 2100.
No.
This goes on indefinitely.
There's no date.
And the sooner we get to what we call net zero, which is back to that equilibrated point where everything is in equilibrium, where the you call the filters and the scrubbers are in equilibrium. We're putting out stuff, yes, but the scrubbers can clean it just as much as we put it out in the filter. Sooner we get to that point where we're back at equilibrium, or even more so that we put out more scrubbers actually, that's where we're going to be able to breathe a sigh of relief and say, okay, well, we've avoided the worst. And the sooner we do that, the better. It's just that these things keep getting worse as we go on, and it increases the likelihood of these tipping points that I talked about, like that ocean circulation shutting off, right? Like, we still, as scientists, we know comparatively nothing about that. We know it's happened in the past. We know this thing's slowing down, but we actually don't know what the consequences will be. We do have a broad idea of what the consequences will be, but it's really still an open question for us, and a bit of a scary question, actually.
Maybe you can help me sleep a little bit better.
Absolutely.
I've got this innate fear. I've had it for a long time that global warming is going to have the opposite effect of what people think it's going to have. So I have this thing in my head where our Earth is warming, and as such, it's going to create like our tectonic plates to move more than they should, and therefore create a volcano that is going to be so big that it's going to block out the sun and lower our temperatures, and we're all going to be plunged into an ice age and die.
Brian, for a question to help you sleep at night.
What?
So first of all, let me separate that. I can tell you that won't happen because global warming and tectonic plates have nothing to do with it.
Completely different, right? Okay.
So they have zero to do with each other, okay? So if that happened, it would be a complete coincidence.
Okay.
But what could happen, and what does have a connection to each other, is things like these, we have big rivers of wind in the atmosphere, right? Well, we also have big effective rivers, currents in the ocean, right? And those currents in the ocean have been responsible for some pretty big changes, right? And so, even things like the fact that if we went to a very hot environment, if there were, take, for example, forest fires, right? We're seeing unprecedented forest fires in Canada right now. Yeah. We saw huge unprecedented forest fires in southeastern Australia anyway in 2019, 2020. All those things put smoke in the air, they put soot in the air. Now, dust is another big one, right? Those types of things actually do act to cool the earth, right? Clouds also can act to cool the earth. And that's because if there's more stuff in the atmosphere, some of those things act as little tiny mirrors. And if you've got lots of little tiny mirrors, they reflect more of the incoming stuff. So things like smoke and whatnot. Our big problem is, though, would that be enough to offset what we're doing, right? So
I'm confused now.
Well, hang on. What do you mean?
If you're burning,
yeah,
like if you have forest fires, you're burning the carbon sink.
Oh, absolutely. There. Yes, and so you've got that as well, right? And so you've got contrasting things. This is where the balance is super complex and where we just don't understand. But this is kind of, I mean, the reality is you're right, you're burning the carbon sink, and so that leads to that positive feedback. But then the smoke in the short term can lead to a negative feedback where it can do a temporary cooling. But the question is, where does this all balance, right? Yeah. Where does this all balance? And so then you have things like these ocean circulations that we're talking about, okay? So would this ocean circulation shut down something somewhere that would rapidly cool? Probably. I mean, maybe, but that would only be Western Europe. Might get warmer down here. Like it makes the climate go haywire is kind of my point, right? And so there's so much that we don't understand. And as I said before, we know the solution to all this. We actually know what we need to do. We've just got to do it. We can, I won't want people to be lying awake at night, sitting there thinking, oh my gosh, this world's, going to hell in a handbasket, basically. Yeah, exactly. Yeah. Literal hell, because it's so hot, which it is at the moment. But it's actually, and I think, from my perspective, I'm actually a relatively positive in the sense that there are good news stories, and I'll tell you what they are. 10 years ago, some of our estimates for future carbon emissions were sky high, right? We have estimates where we kind of have to make guesses around what society and the economies are going to do about the future. Some of those guesses about the future are like, well, actually, what happens if we move to a really green economy where we have high penetration of renewables and we do, what would the emissions look like then, and then what would be the consequences for the climate, right? Or the opposite end of the spectrum, what happened if we just keep going gangbusters just like we are now, right? And what would be the consequences there? I mean, the good news is that those ones at the very high end of the spectrum, the worst ones, we actually don't think they're realistic anymore. And that's because of things like the fact that even though a lot of governments haven't necessarily been doing stuff about directly lowering their emissions, people have taken it upon themselves to put solar on their roofs. Yeah. I mean, some of that's been through government incentives and stuff like that, but this is happening worldwide, right? Yeah. People have moved towards electric vehicles, right? These things, particularly with what's happening at the moment in Iran, I mean, something like 1/3 of all the vehicles sold in the last few months in Australia has been electric. And so you've got these types of things that kind of happen quietly in the background that then when 10 years later we revise our estimates of what's going to happen into the future, there is a little bit of good news, So I think it's pretty safe to say from most scientists that absolute worst case, we're emitting like we did at the rate of increase that we did 10 years ago, it's probably not going to happen now. That's not to say that bad things like, we're still emitting at a rate that is too high. We are. But, at least if we continue on the trajectory that we're on now, and, hopefully accelerate that, it could be worse. That's what I'm saying.
I may sound like a pessimist, but I'm not. I'm a realist. And optimism comes from realism. Otherwise, we wouldn't do anything. We wouldn't bother. That's right. We would just say, what's the point?
Exactly. You've got to have hope, right? Yeah. You got to have hope. And I think there is hope in that respect. I mean, that's still not to say we're not going towards a world of 2 to 3 degrees of warming. I think we are at the moment. But it's just that we're maybe not going to a world of 5 or 6. That's all.
Yeah, 5 or 6, I don't think is sustainable. I think that's where the world just says, nah, I've had enough.
No, it's not. I mean, 5 or 6, you're talking about, 45-degree days in summer becoming a semi-regular occurrence multiple times a year. But
I think at that point, your air currents in the world will change so dramatically that your ocean currents will change, and the whole thing will just it'll go tits up. Yeah,
that's a good way of saying it. Yeah, exactly. Yeah. So, I mean, yes, this is the question, and I mean, it's as I said before, it is reversible. It's just the sooner we do things, the better. So, we definitely need an acceleration of the reduction in greenhouse gases.
Right.
So,
Or a
Ali,
deceleration, yeah.
so just to bring it back to, I suppose, what our industry can, I suppose, focus on, and what we focus on, ultimately, Sustainable Builders Alliance. What would your predictions be over the next, firstly, I suppose, over the next 30 to 50 years? Presumably we're going to get to the 2 to 3 temperature increases on average. What can we expect in a world like that, I suppose, with climate, with weather patterns, and with the 1 in 100-year floods that happen every 10 years?
Yeah. So it's really going to depend where you are, to be honest, on the effects that you get. If you're up in Northern Australia, you can probably expect it to get an awful lot wetter, more hot, more humid. Whereas if you're in Southern Australia, everywhere from Perth to kind of even Brisbane, but Perth to Melbourne in particular, that whole stretch looks like we'll be getting probably less rainfall in the winter. Everywhere will be getting hotter. If you want to think about the worst summer heat wave that we get now, those, instead of being once every kind of you think back to those heat waves where you're like, oh, yeah, remember that one from 5 years ago? Oh, that was shocking. That was, oh, yeah. I mean, I'm from Melbourne, so I always compare it to Black Saturday in 2009 where we had like 3 days above 43, which for Melbourne's a bit weird because we often get the fronts come through that just knock down the temperature, but we didn't. And, events like that relative to where you are, instead of occurring once every 5 years, might become multiple times a year. I'm a big skier and
terrible season.
Good luck doing that in Victoria. There'll be snowmaking, and it's not to say that it won't be something there. But, as we get towards the end of this century, I mean, I think we'll be right in the next 30 years with snowmaking and whatnot. But as you get towards the end of the century, that changes everything. Right? I mean, I wouldn't suggest that I would suggest that that's an unlikely possibility to be skiing in Victoria by 2100.
And sorry, you have a focus on droughts.
I do,
Can you speak at all to the change? I mean, this is a big impact for a builder like Brian and I.
Yeah.
The change of that with our soil conditions.
Yeah,
how might that change the way a houses or a home's foundations move?
Yeah, absolutely. Well, I mean, this is the thing, right, is that, it kind of changes everything from that to landscaping and the types of plants we put in our gardens and whatnot because, I think you guys are from Perth, is that right?
I am.
You're in Perth, I'm in Melbourne.
Ah, there you go. So, I mean, Brian, where you are, you guys have had a decrease in rainfall since the 1970s.
Consistently, yeah.
That has not ever gone back. And that's actually a big climate change signal there.
Yeah, huge.
And so, you guys are actually a bit of a
case study.
In what could happen elsewhere. So in Melbourne, we're seeing similar things, but not to the scale that you guys have got over in Perth.
Very isolated, though.
Yeah. And so So think what's happening there and how you've adapted to that, because that's kind of what could happen elsewhere. And
I don't think they have. That's the problem.
Yeah, right.
Nobody's adapted, and I think water is still too cheap.
Well, and the interesting thing is the way that Melbourne does it and the way that Perth does it. For example, Perth just builds desal plants.
Yeah.
Right? And so that is an option, right? And that is a perfectly viable option. But the problem is that desal plants are very, very energy intensive.
Yeah.
The water is actually a lot more expensive.
They're pretty shit for the environment too.
Yes.
To be fair.
Yes. Very, very, right? So the question is, how are people going to adapt to these things? Perth's adapted to it with desal. Melbourne has adapted to it maybe not so well yet. I mean, Melbourne's running out of water, I have to say. We're in the middle of a drought right now. In terms of droughts, we do expect to see more longer time spent in drought. So when I say drought, I'm not talking about just kind of dry conditions. I'm talking about those really bad dry years, or months or whatever. We do expect to see more time spent in those super dry conditions. That said, in some places we're also expecting to see a bit more maybe shifts in how rainfall works, seasonality of rain, stuff like that as well. There's still a lot we actually don't understand, to be fair. And
just
still
the
a
wheat
lot.
belt in Western Australia itself.
Yeah.
It's a gamble.
It is.
Every
it is.
year, it's millions and millions and millions of dollars for farmers.
Absolutely. I mean, but take the Southwest wheat belt. That's a really, really good example because so far they have been able to adapt with GM crops, right?
Just about.
But that decline in rainfall is projected to continue.
Yeah.
There's going to be a point where GM can't help you, right? Where is that point? That's kind of the question, right?
Now we're talking about like food security.
So, 100%.
Yeah.
Well, I
And
mean,
it's a real issue.
it's already a real issue. I don't know if you recall, even the last couple of years, you will see stickers on your supermarket shelves saying, sorry, due to the floods in New South Wales, our supply of lettuce is reduced. We can't get this in for you. Or strawberries go up to $12 a punnet because we've already seen this. I mean, I don't know if you guys remember back in, I think it was when would it have been? 2011?
No, that was
bananas. Yeah, Cyclone Yazi knocking out the banana crop, right? So this actually already happened.
$18 a kilo or something.
Yeah, absolutely. I actually moved to the United States at the time. The first thing I did when I got there was buy like a huge thing of bananas and just eat them all, and everyone was looking at me really strangely. Like I haven't had bananas for a year. Yeah, I mean, we already see these types of things. It's just that these types of things will become more prevalent and hurt the hip pocket more often. I mean, half of the increases in cost of living that happened in 2022, yes, COVID, but it was also the floods.
Yeah.
Massively.
Yep.
Right? Because they knocked out a whole bunch of crops and they knocked out a whole bunch of, and you think about global supply chains and wheat and stuff like that. I mean, there's a whole heap of knock-on effects. But getting back to the drought question, we do expect to see more time spent in drought, particularly in southern Australia. So, and that's kind of year situations. Yeah.
Gotcha. And is it floods on the other end as well? Is it expected
both
those?
ends.
Yeah. I mean, floods in parts of southern Australia are still an open question. We don't quite know what will happen with that. And this is where the science is still telling us a lot. For example, we know here on the East Coast anyway, we're relatively strongly affected by things like, you guys might have heard of El Nino and La Nina.
Yeah.
So this is these big kind of climate patterns in the Pacific that just seesaw every few years and whatnot. A lot of our models tell us we might be heading into a more El Nino-like world, which is, more conducive to drying. But then also there's also a question of, if we moved into a more La Nina-like world, which is also a possibility, that's floods. That's Brisbane floods every, that's kind of – so there's still a lot of open questions.
There's no way to determine that as such. Like we just know the temperature's going up steadily and
I mean,
whatever
and
the world wants to do, it'll do.
Yeah, so that's the thing, isn't it? That we can be exceptionally confident that we're going to get more heat waves, stronger heat waves. Like it's going to get hot. Your winters are not going to be what they were. I mean, here in Melbourne, Simon, I'm not sure if you've noticed that this winter's been exceptionally warm.
Yes.
And
we had about a week of it. That's it.
Yeah, right. And I mean, it's and this is kind of becoming the norm now. In Melbourne, we used to get weeks of 10 degrees in the winter, and it just doesn't happen anymore. Or it
18 degrees last week in July.
Yeah, in July.
Yeah, we had our hottest day on record in winter. 2 weeks, last week or the week before in WA.
Yeah. As I said, I'm a skier, and Mount Hotham in Victoria had 12 degrees as a maximum the other day.
Wow, in July.
Middle of winter, 12 degrees. And it was the hottest on record.
Wow.
Right, can we do something really quick if we can?
Yeah, of course.
Can we actually define greenhouse gases, please?
Yes. So greenhouse gases are any gases that basically clog that filter. They are the gases that really love what we call infrared radiation or heat. and they love to soak it up and re-emit it back to the earth, right? They are the blanket.
So the primary one is?
The strongest one or the most abundant one? Which one?
Well, let's go by cause and effect. So what's the one that we're emitting the most as a human race right now?
Carbon dioxide.
Carbon dioxide is the primary,
Yep.
right?
Yep.
That's kind of where
That's
I was going. Right.
That's right. So carbon dioxide is the big one, right? Yep. That is what we are emitting the most of. That has a significant effect. The other problem with carbon dioxide is it lasts an awful long time in the atmosphere.
Yeah.
You emit a gram of carbon dioxide right now, it'll still be around something like 20 to 80 years from now.
Right. Wow. So it's not completely irreversible. But
no.
Carbon dioxide is anything that's a fuel burned, essentially.
Yes. The next one is methane.
Yeah.
So those are the two big ones, but carbon dioxide is far and away the front runner. That is what we need to reduce because that is what burning gas, coal, even wood, all that kind of stuff, that is what is the primary thing that is emitted, and that is the majority of what's clogging that filter.
Do you have any numbers for us? So basically, what were we burning in 1970 versus 2020 versus 2026?
So basically, we kind of measure this in it's a unit called, like we say, how many parts per whatever, right? So if we have a gram of air, how much is in the air, right? As parts per unit of air.
So the saturation.
Yes, exactly, the saturation, right? And so before we started emitting fossil fuels extensively, I think we started at 280. I can look it up very, very quickly. Hang on. But right now, let me have a look what we're at. Yeah. So we started at about, I think it was, hang on.
So that's 280 milligrams per gram?
Yep, 280, exactly. So 280, right? Okay. So 280, parts per million.
Oh, sorry. Okay.
Actually parts per million. Tiny fraction, right?
Yep.
Started at 280. We're currently at 430 or a bit over 430.
And that's like 250 years.
That's not even.
No. 200
really,
years.
So 100 if that.
No, not even 100 years.
Really?
Yeah.
Yeah, like 50s.
Yeah. So things did start but the problem is there's an exponential increase, right?
Yeah.
Things kind of traveled along like this for a while, just increasing, and then it was more the 50s that really started spiking it. But you can see the increases from about the 1920s or so, but the last little whiles, really ramped up. So we're at 432 now. So
and just to say, previous to the, if you want to say the 50s, it was basically that for how long? 1,000, 2,000?
Let me think.
Multiple thousands of years, wasn't it?
Oh, no, not thousands, millions.
Yeah. Millions of years.
Yeah.
Well, it would have varied a lot, though, because when you've had...
Oh, it does.
Yeah, it varies as the Earth changes. So as you
I don't think but not like it has in the last...
No, so the problem is not the amount of carbon dioxide. We've actually been in situations where we've had close to, like, as I said, we're at 430 now. We've been in situations where we've had 800, but that was back in the time of the dinosaurs, right?
Yeah.
There were good reasons for that. And not only that, when you're talking about these past changes, I don't think we quite realize the timescales we're talking about, right?
Millions of years.
We're talking about, right now, we're talking about a 55% increase in 80 to 100 years, right? Prior to that, we were talking about a increase on the same scale on the order of millions of years. Millions.
And at the rate we work and how, like, as a race, how quickly we move, it's scary. Because you can do more in 10 years now than you've done in 50 years previous. You could probably do more in 2 years.
Correct. And so this is why our natural systems are really not coping because, when they adapt, when these changes have occurred in the past, they've had millions of years to evolve and deal with it, right? Yeah. They don't have that now. So, yeah. But look, as I said, we can do something about this. And I think building
100%.
sustainable homes, plays the part. Making sure that we are conscious in what we're doing, but also encouraging, voting with our wallets is a big one, and voting with our votes is another big one, to encourage both our politicians but also the companies from which we consume to lower their carbon footprints.
Yeah. So that's the key, I think, because everything in this world, unfortunately, is driven by numbers, because that's where we're geared.
That's right.
It's all based around money.
Yes.
That's just, we educate our kids on numbers and money, and
that's right.
And so that's just how the world works.
And so we need to get to a point where it's actually cheaper to be a low emitting or no emitting.
Yeah.
And that's the point.
So if we make it financially viable for all the big players, they'll do it. They don't care, because they just want to make money.
Correct. And I think we're kind of starting, well, we have hit that tipping point in Australia, right? In the sense that renewable energy is now cheaper than coal and gas, right? Yeah. To make electricity from renewables is cheaper. But that's not true the world over. And
we're one of the biggest offenders.
Well, per capita, though. It's because we've got a small population, right? And so if you actually look at how much we emit in raw numbers, it's relatively small.
I disagree with that, but that's okay.
I
think we ship a lot of it overseas.
Well, we do.
That we do not take account for.
100%. 100%. No, that's a very true statement, actually. A lot of the gas that we ship overseas is used in the coal as well, 100%. And oftentimes that's not in local accounting. No.
And even all of the minerals that we send overseas, like iron ore and aluminium, all this stuff that we send overseas is smelted elsewhere.
Yes.
That's our responsibility.
No, absolutely. And so if you count all that, yes, we're an awful lot bigger. But if you're thinking about just like electricity generation and stuff onshore. But yeah, absolutely. So, it's really about making good choices, I suppose, climate conscious choices, really.
Absolutely.
In everything we do every day.
So, Ailie, if somebody gave you $1 million or $2 million to build a home for your family and for the future, what would you build, and how would you build it? What would be the considerations for you? Knowing what you know,
I would definitely be making it lowest footprint that I could, lowest carbon footprint that I could. I would be,
that's altruistic to help with our. So that's altruistic to help with our problem.
Absolutely. I'm a big fan of rammed earth, actually. So I reckon I'd do something rammed earth. Passive solar is a big thing that I like. I would be having a north facing everything. Lots of panels. I would be making sure that to the best of my ability it was, I'd love an off-the-grid place. That would be amazing. But, don't know if that's realistic for where I am. But passive solar, and it would have exceptionally thick walls. I'd try and make it passive, but I don't know that kind of, I don't know. You guys are building experts. Does that work in reality?
Yeah.
So I think that's where I'd try and be. I'd have a very water and fire appropriate garden, lots of natives.
Yep.
Try and retain that soil moisture. But I'd also probably be building in some extra specs for excellent drainage in the event of very heavy rainfall. So that's what I'd be doing as well, because, it looks like we'll probably be getting across most of the country increases in very, very short duration extremes. So these are kind of the showers that just go bang and then stop 5 minutes later. So it's interesting. All the rain doesn't necessarily, like the rain itself, when we get big rainfall, doesn't seem to necessarily be changing, for example, down south. It's just falling in a quicker period of time.
Yeah, that's right. The amount of rainfall per annum is not changing. No. It's the volume in which we get it in short periods.
No, but see, that's the thing. Down here, for example, in Perth and Melbourne, the amount of rainfall per annum is changing a little bit, but it's decreasing. Yeah. But then it's like when it rains, and particularly when you get those extreme rainfall events, that's when it just bang. So that's why I say good drainage.
Can I ask a silly question? Sorry again, Simon. I keep hijacking. When I came to Perth first, I noted when I was here first, in the first few winters, it seemed to rain at night and not really during the day. Not much that I noticed anyway. And in the last few years, I've noted that it seems to rain a lot more in the day, and there are bursts of rain. And then it seems to just you don't get any value from it. When it rains at night, it's not as hot and it doesn't evaporate as quick. And maybe that's just I think I'm off my mind.
The problem, weather's so variable that it could just be coincidence. I don't know, but interesting point though. Yeah.
So you mentioned about building for floods. So with respect to that, I guess that's touching on future proofing for climate resilience.
Yeah.
So what else would you do besides that? Is there anything that you could give advice to owners or builders? Well,
I mean, I suppose in much of the country, in summer anyway, it depends where you are, right? I mean, if you're up north, I'd also be a bit worried about cyclones and making sure your building standards were there.
Do you think there'll be more cyclones in this?
Well, we don't think there'll necessarily be more cyclones. The jury is still out. The evidence is murky, but our best evidence at the moment is that the cyclones that do occur are likely to be more intense. Mm-hmm. So you might get fewer, but when they hit, they pack more of a punch, right?
Intensity seems to be the theme.
Yeah, exactly. So, same with rainfall, right? And I would be more worried about kind of floods, particularly northern New South Wales coast and up through southeast Queensland. Definitely flooding and heavy rainfall is something that you want to consider. Down south, it's and also in the summertime, actually, humid heat. It is becoming a bit more humid up there as well. So it's not just about heat; it's about humid heat. Mostly up there, though. Little bit down south as well, but is really about protecting from heat and extreme rainfall. Those are the two biggest things. Wind, we have no idea about, to be perfectly frank. There's not much. There's still so much science to be done on specifically weather changes, and that's what our group. So I'm part of a centre called the Centre of Excellence for Weather of the 21st Century, and this is kind of what we're trying to understand is weather change with climate change, because people always talk about climate and averages, but we're like, well, actually, it's the weather where things really hit home, and we actually don't know a lot about weather, like weather systems and things like that, like cold fronts and cyclones and stuff like that. So that's what we study. So in terms of wind, the jury's kind of still out, actually.
So is there potential then for climate zones to move or change?
Yes.
So right now we've got 1 through 8 across Australia. Is there is there potential? Because right now we're building to climate zones. You know what I mean? For moisture management through our structures, etc.
Yes.
So when it comes to vapor permeability and all that kind of stuff, we're really conscious of all of that. Where does that sit?
Absolutely. That would definitely be something to consider in terms of changes for sure. I didn't know that actually. Now you've got me thinking maybe we should look into this and changes in those zones. But yeah, I mean, those zones are built around kind of climate averages, and those are changing. So most definitely. I remember seeing some work, and this was many years ago now, where some of the projections had, for example, Melbourne being more like the climate of Dubbo by the end of the century. So, if you're building a house that you want to last 100 years, maybe you should be building to something more like central New South Wales than something like Melbourne. So it's a real question of, and I think, as I said before, I think part of the problem is we actually don't, we as scientists, we haven't looked into things like those zones, right? We should.
Because that's what we're basing it all on. We're basing all of our building on those zones.
Yeah, right.
That's how all of our modelling is done. If you're doing building passive house, all your PHPP modelling is done on climate zones.
Yeah, right. Well, I'm going to take that away from this podcast actually and take it back to the team and see if we can't start looking into that.
Yeah, all of your NCC as well, like your National Construction Code climate zones. It's all based on that. So if
Yes.
that's changing,
Yeah.
maybe that needs to be.
Yeah, I know there has been some work with the NCC that some of my colleagues at CSIRO have been doing around that kind of stuff, because this is exactly it, And I mean, we're talking about, we're talking about a lack of housing and building more housing, even things like social housing, right? And my question is around things like social housing. Are they building to the climate of 30 years from now? Because I mean, I'm assuming, I don't.
Not.
50
They're not
years?
building for the current climate, if you
No,
ask me.
right. So
If you're building in a national construction code right now.
yeah. So it's something that we should all be thinking about for sure.
I mean, Brian, it's even more reason for what we push is to build above code. Because the code's going to change in the next very soon, and I mean, climate's changing inevitably.
Yeah, absolutely.
Well, I think this is the point: is that you talk about changing, and we kind of think, oh yeah, we just need to change the codes, but this is not our new normal. This is actually our changing normal.
Yeah.
So this is the other issue that we have to think about, is that, until we really take our foot off the accelerator and we really do start to reverse this, which at the moment doesn't look like it's happening anytime soon, to be honest with you. We would like to talk about the fact that it will, but I'm not seeing any evidence of that at the moment. I mean, it's slowing, but not at a rate that we need it to slow. But the point is, things will keep changing. And so you can put in new building codes. You can put these things in practice, and that's fine. They might be good for 20 or 30 years, and then they need to be changed again. And then they need to be changed again, because this is a changing normal. It is not a new normal, right?
Yeah.
So that's the other thing to think about.
It certainly needs to be thought about. We have a lot of people coming to us, don't know about you, Brian, but especially with the price of housing, people want to build generationally. So they're building for themselves and their kids to then stay in the home.
Yeah.
And you don't want to burden your kids with an
underperforming
underperforming home in 20 years' time. It just doesn't deal with the climate that we have at that time.
Yeah.
Yeah, it's necessity now at this point. It's absolute necessity.
Yeah,
it is.
All right, Ali, I think we've taken enough of your time. Simon, you got anything else, mate, before we...
Nah, I learned a lot. Thank you, Ali. That was excellent.
No problem at all.
Yeah, I absolutely gobbled this up. My antenna goes off and I just fucking love it. Absolutely love it. All right, let's get through the quickfire questions, Ali. Who's the most famous person in your phone book?
Oh, they're probably all nerdy climate scientists who you wouldn't know. So
Yeah, right.
I mean, some of Australia's leading climate scientists, but I don't think they're particularly well known outside my circles. But that's about it, really.
Have you heard of a guy called Zach Bush?
No, I haven't.
Look him up. He's not necessarily to do with climate. He's an interesting guy, though, especially when it comes to the Earth's biology and everything.
Yeah, cool.
He is an interesting cat.
Yeah, nice.
Favorite sporting team?
I'm a Western Bulldogs supporter, so them and in my house it's a Matildas thing.
Yeah, right.
My daughter's very into the soccer, so Matildas and Western Bulldogs.
Awesome. Passive house or passive solar design?
Oh, probably passive solar actually for me. I reckon. Okay. I love sunshine, so yeah.
Timber, brick, or alternative construction?
I like alternatives.
Yep.
I don't know. I really like rammed earth. I really like, I don't know, anything that's kind of very earthy looking, I think is great.
Have you seen or heard of Earthships?
No.
Go have a look.
Yeah,
Google it.
Will do.
You'll enjoy that. That's a good one.
Yeah, nice.
Favorite music?
Oh, look, I love a bit of 80s and 90s pop, I must say. I'm a bit old school like that, but I like everything. But
disco music.
I do like, well, look, I was a massive Spice Girls fan in the day. So
so was I.
I will.
Who wasn't?
I will admit to cranking that up. You know, that's very good.
All right. Tim Tam or Anzac?
Well, that's a toughie. Probably Tim Tam. But only, it depends on the day, actually. Sometimes wait, I do love an Anzac. Oh, that's a hard one. I don't know. That.
Good disclaimer there. Depends on the day. I like it.
Yeah, that's a political answer, that one right there.
Yes.
It is.
Ali, thank you so much for joining us. It's been an absolute ripping conversation. I love it. Thank you so much.
Yeah, no worries at all. Anytime. Thanks.